So we're going to be talking about how to calculate pH for AP Bio. This is going to be slightly different than how you're going to calculate pH if you take chemistry or AP Chemistry. It's going to be a little bit more in depth. So we're just going to go over today what you need to know as far as calculating pH for AP Bio. So first, it's good to have a good understanding of what makes something a base versus an acid. So remember we talked about this in the PowerPoint where an acid is characterized by having H plus ions and a base is characterized by having OH minus ions. Now it's important to note that in a solution, you're always going to have both ions present. So it's not like in an acid you only have H plus or in a base you only have OH minus. Usually you have both. Whether or not something's acidic or basic is going to kind of depend on those levels. So sometimes I look at this like H plus is usually acids are red and bases are usually characterized by the color blue. So another way you can think of this is hot water and cold water. So, generally when you have a bath or you make a bath, you're going to have some kind of combination of hot and cold. Just the overall temperature feel is going to depend on the levels of hot or cold. So if we go kind of in the middle, neutral, that's where you're going to have equal amounts of H plus and OH minus. So this would be like a lukewarm bath where basically you have equal amounts of hot water and cold water. You've let both taps run at the same rate. And then what happens is as you shift on either side of the pH scale, depends on what happens to the amount of acid or the amount of base. So as you shift towards the acid side, what happens is the amount of H plus goes up and the amount of OH goes down. So this would be like you only having or putting a lot more hot water in a bath versus cold water. You still have both temperatures of water. You still have H plus and OH minus. It's just that you've added so much hot water that the general temperature of the bath is going to be hot. So again, you have H plus here, you have OH minus in this acidic solution. It's just you have so much more H plus ions, they overpower the OH minus, and that's how you get an acidic solution. And then the opposite is true for basic solutions. This is where you're going to put a lot of cold water in a bath. So you still have some hot water, you still have some H plus ions present. It's just you have so much cold water, so much OH minus that it's going to be towards the basic scale. And as you move back and forth between the pH scale, you see this level, they kind of interact with each other. They're indirectly related. So the more H plus you have, the less OH minus. And the more OH minus you have, the less H plus. And then those kind of things work together to give you a pH. Couple of other things here. There's a couple of definitions that are important for you to know. So pH is kind of generally what we talk about when we talk about measuring acidity, but pH in particular is going to measure just the H plus. Whereas down here you see this thing called pOH. That measures the amount of OH minus. So they both tell you, it gives you an idea of the acidity or basicity of a solution. It's just kind of in different ways. So what happens is if a pH is less than 7, in the pH scale, we consider that an acid. So basically, the lower the pH, the more acidic something is. And then the higher pH, more basic it is. And it's going to be kind of opposite with pOH. The other thing here is this bracket. So these little brackets here, the brackets stand for concentration. So when you look at this and you see that the H plus concentration is 10 to the 0 or 10 to the negative 4th, that is telling you how much H plus concentration is there. So the brackets here, again, is concentration, and they're down here with OH minus. And then all this stuff together, all this information is going to give you an idea of the acidity or basicity of a substance. So before we start doing the actual problems, I think it's important that you know some formulas that in general you will have to know for these problems. These formulas are actually given to you on a formula sheet that you're going to be able to use for the AP exam. So there's no real reason for you to memorize these. I would just have them kind of handy on a piece of paper, or you can even write them right on your worksheet to do these problems. So the first formula we actually talked about in the PowerPoint, and that is that pH is equal to the negative log of the H plus concentration. So again, this looks a little scary. It's not. Log here is actually a button on the calculator. I'm going to show you what button that is. So this whole segment here of the formula is just a button you would push on the calculator. And then remember, we just went over brackets mean concentration. So what this is talking about is how much H plus is given in a particular problem. So what's going to happen is a lot of times this is going to be given in the problem. The problem's actually going to say, you know, the H plus concentration equals whatever that may be, and that's what you're going to use to calculate H plus. So that formula looks a little scary. Once we use it, it's really not that scary. The other formula that looks very similar, although it's not quite the same, is POH is the negative log of OH minus concentration. So you can see it's very, very, very similar. It's just that instead of talking about the H plus, you're referring to the OH minus. So sometimes you're given this, the OH minus, instead of the H plus, and this is just a way to calculate that given a different type of problem. These two, pH and POH, go together with the formula of pH plus POH equal 14. So this is where we get the pH scale being 0 to 14. It's from this idea here. So the pH of something plus the POH of something is going to give you 14. So sometimes you may have the pH and you need to find the POH, or vice versa, and this formula here will help you get there. So now we're going to do some problems to see how we use these formulas. So the next set of equations you may need is if you're given a pH, how do you find the H plus concentration? So if you're trying to find the H plus concentration, that's going to be 10 to the negative pH, and that negative pH is an exponent. And then kind of very similar, if you're trying to find the OH minus concentration, that's going to be equal to 10 to the negative POH. So again, the POH is an exponent. And this last one you may not even use, so I'm going to put this in a slightly different color because you probably don't need to use this. You can work around it, but just in case, very similar to the pH plus POH equals 14. The concentration of H plus times the concentration of OH minus should equal 1 times 10 to the negative 14. So this could be used if you have one concentration and you need to find the other. So like if you have H plus and you need to find OH minus. But again, there's other steps you can take to find that as well. So I just left that one in green. That's like just in case you need it. Okay, so this is a problem directly from your worksheet. So I'm just going to give you a sample problem directly from there so that you can kind of work along and figure out how to do it. Remember, it's not really important that you can write down this problem, that you're copying it down from me. It's more important that you understand how to do the problem. So one thing with AP type problems is it's really good to understand what the question's asking. A lot of times the questions are going to be written in such a way that it's a little confusing, just even figuring out what they're asking. So a good thing to do would be underline or highlight as you're reading to figure out what information you need to know. And now obviously it's very important to read the whole problem. Read it. Probably more than once would be good. So this says water molecules can dissociate into hydronium ions. And remember the parentheses, hydronium is often just H plus for short, which is what we talk about, and hydroxide ions, OH minus. The concentration of these ions in pure water is 10 to the negative 7th. In other words, in pure water, 1 out of every 10 million molecules is dissociated into a hydroxide and hydronium ion. So we're going to pause for a second and figure out what we can get from this part of the problem. So number 1, we're going to remember that H plus ions indicate an acid and OH minus ions indicate a base. So what they're essentially talking about here is in pure water, acid and base ions are equal, which we already talked about that. The amount of acid and base in pure water, they're going to be equal to each other. So let's keep reading. The H plus concentration of a solution can be represented by the pH. The pH of a solution is calculated using the equation pH equals negative log of H plus. And again, that's an equation we have. So here comes the question. So sometimes it's a good idea to kind of use another color and circle the question so you know that you're answering the right thing. So it says, what is the pH of pure water? So you might be like, well, how do I do this? Where do I start? What do I do? Well, number one, they give you the formula here, pH. And that's really one of the only formulas you're going to have to calculate pH. So you should know right away, because that's the only formula you have, that this is the formula you're going to need to calculate the pH of pure water. So remember, breaking this down again, pH is equal to the negative log of the concentration of H plus ions. So in order to calculate pH, what you need is you need this concentration of H plus ions. So you might be like, well, wait, I don't have that. I don't have that anywhere in the problem. How do I know what the concentration of pure water is? Well, if you read carefully, you'll see that they gave that to you right there. The concentration of each of these ions in pure water is 10 to the negative 7th. This is just a shortened way of writing 1 times 10 to the negative 7th. So that is actually equal to the H plus ion concentration of pure water. So the way you're going to write this up is you're going to do pH equals the negative log. And then here now I have a number to put into this bracket here. So I'm going to do concentration is 1 times 10 to the negative 7th. So I'm going to show you in a second how you would do this on your calculator, how you would plug this in. But what's important to know, and this is going to be for AP Bio and all AP Bio problems, this might not be the same in AP Chem, but if you have a 1 times 10 to the anything, if this first number is a 1, because a log is a base 10 property, what essentially happens is if you take the log of a 1 times 10 number, the log and the 1 times 10 actually cross each other out. Just like if you were going to do 1/2 times 2 over 1, the 2's would cancel out. That's actually what happens when you put this in your calculator. And then again, you have a negative, and the negatives cross out. So if you have a problem where it's pH equals negative log of a 1 times 10 number, the pH is just going to be equal to the value of the exponent. So in this case, pH is just equal to 7. So because the negatives crossed out, because the log and the times 10 crossed out, all I'm left with is the value of the exponent, and that's going to be your answer. And for AP Bio, that's pretty much going to be every problem. In every problem, they're going to give you a 1 times 10 number. So the pH is really just going to be equal to the value of the exponent. That's kind of a shortened way to do it. Now I'm going to show you how you would do this if you want to actually plug it into your calculator. Okay, so if you want to know how to put the problem from the previous slide in your calculator, how you would actually plug this in, I just have a picture here of a classic TI-80 calculator. It's pretty much going to be the same, whichever calculator you have, TI-84, 87s, all those. If you have a very, very new advanced TI, it might be a little different. So if you need kind of help how to figure that out, you might want to take a picture of the calculator and I can show you. But what you're going to do, remember, is this is going to be divided into sections. So I'm going to first show you all the buttons you're going to hit. So you're going to hit the negative, you're going to hit the log, and then you're going to plug in the number there. So the way you would plug this in your calculator, I'm going to show you what it would look like too on the printout, is you would first hit the negative button, and what you would see is the negative button appear on the screen like that. And then you would hit the log button, which is right here, and it literally says log, L-O-G. And that's actually going to appear on your calculator. It's going to look like that, negative log. It's also going to have an open parentheses, which is where you're going to put your number. And then you're going to put in this 1 times 10 to the negative 7th. So there's actually 2 ways to do this. The first one is to do 1, so 1, and then times, it's going to look like a star, remember, and then 1 again, and then 0. And then you can do the caret up. So right here, this kind of 2. That is the power button. So it's going to be 10. And then you're go down here again, and you're going to do negative, and then 7. and then go ahead and close those parentheses. And that would pop up, and you would hit then enter, and that would give you the answer. So that caret is fine. It will work, but there's actually an easier, quicker, more efficient way of doing it rather than the caret. It's going to be helpful for you, especially when you go into AP Chem, because AP Chem is going to have, again, it's not going to be just a 1 times 10 number. It's going to be a little bit more complicated. So I think the better way to start practicing to use this is to do this. So again, you're going to start the same way. You're going to hit the negative, and you're going to hit the log button. It's going to show up like this. And then you're going to hit the 1. Now, pause. Instead of having to put in the times 10, caret, etc., there's a button on the calculator that kind of takes the place of times 10, and it is a little e. So this is how you find it. You're going to hit second, and then this button here that looks like a comma right over the 7. And you see in the blue letters it has a little two uppercase e's. When you hit that button, it's going to come out like that. It's going to be 1 uppercase E that's going to be times a little smaller. This E here stands for the times 10. So you do not have to put in the times 10. That E right there stands for times 10. So then all you put in after the E is the exponent. So you would do negative again, and then 7, and then close the parentheses, and then hit enter, and that should give you the answer as well. The advantage of using the second E, the times 10 substitute, is sometimes when you have to use the caret, you would have to put something else in parentheses to keep it in the correct order of operations. So the times 10 takes all that away. So you would just, again, do the 1 here, and then you do second here, and then the little comma above the 7. That's going to show up a little E. And then you don't have to do the times. You don't have to type in 10. You don't have to type in the caret. All you do is type in the exponent after the E, and that should give you the answer. So finally, we're going to do one more practice problem. It's going to be, a little bit more difficult because, again, this is how AP is going to work. So this says that the pH of a solution is 6.5. So I'm actually given the pH this time. So the question is, what are the H plus and OH minus concentrations of the solution? All right. So I have the problem. I've read it. I know the pH equals 6. So I can write that down. 6.5, sorry. Now, this problem's a little different. It's not asking you for the pH. It's not asking you to do the pH equals negative log times H plus. But if you recall in the formula section, we did find a formula that would take the pH and let us find the H plus concentration. So if you see that, you know that. So you're going to do the concentration of H plus is equal to 10 to the negative pH. Remember that pH is an exponent. So to solve this, all you're going to do is you're going to do 10 to the negative pH. And then if you plug that into your calculator, again, you would do the 10, 1, 0, and you can choose to do the caret, negative 6.5, or you can do the E to the negative 6.5. Either way, you should get the answer that H plus is equal to 3.16 times 10 to the negative 7th. And the unit is actually going to be molarity. Now, some of you may be thinking, well, can't you just do the reverse? So like if 1 times 10 to the negative 6.5 is going to give you 6.5, couldn't the answer just be 1 times 10 to the negative 6.5? And the answer there is kind of yes, kind of no. Yes, that would work. That's actually what would work in your calculator. But the problem with that is that you're going to have, they don't like exponents to be in decimals. That's why it kind of looks different when you put it in your calculator. Like the negative 6.5 isn't real nice decimal wise. So if this comes up, I wouldn't say you'd be wrong with that. If you want to go ahead and use that as the answer, you're not necessarily wrong. But I would say the more correct way is to plug it in your calculator and get the 3.16 times 10 to the negative 7th. So please note, we've only answered this part of the question. We have not answered the whole question yet. So the other part of the question is, what is the OH minus? So there's a couple ways you could do this, but probably the easiest way is going to bring in another formula, which you remember the pH plus the POH should equal 14. So if I know the pH is 6.5, I can calculate the POH by subtracting 6.5 from 14. And that's going to give me a POH of 7.5. And then from here, you kind of use very much the similar equation of OH minus. So the concentration of OH ions is equal to 10 to the negative POH. So you do 10 to the negative 7.5. And again, you'd plug that into your calculator using either the caret or the the times 10. And you get 3.16 times 10 to the negative 8th molar. And again, could you just do 1 times 10 to the negative 7.5? Same kind of idea. You're not totally wrong, but the decimal being in the exponent is kind of the issue with that.